Hello. Today I wanted to make a video on router on a stick. I wanted to talk about trunking and subinterfacing in order to do inter-VLAN routing. So the way this network is set up right now, I have two different VLANs assigned, but these VLANs cannot communicate with each other inside the network because I haven't set up inter-VLAN routing yet. And that's what I'm going to be doing in the video today. So two things that you have to have set up and configured to do inter-VLAN routing is you have to have a trunk port. And a trunk port is basically going to be this one single cable connecting switch 1 to router 1. This is going to be your trunking line. And what that means is that allows traffic from both VLAN 20 and VLAN 10 to use one single trunk interface. The other thing that you have to configure is subinterfaces. So typically in a network, you would have on your router, the interface that's connected to the router would make up your entire network, and the interface of FA0/0 would be configured with an IP address, and that would be your default gateway. When you're doing inter-VLAN routing, you actually have to create subinterfaces. What that basically means is that you're creating a default gateway for VLAN 10 and another default gateway for VLAN 20. So you're basically splitting this interface of FA0/0 into two different subinterfaces, which allows VLAN 20 to communicate with VLAN 10 and vice versa. So the first step is you're going to want to go into the switch and type in interface FA6/1. So interface FA6/1 is this interface on the switch going to the router, and we want to enable trunking on that interface. Let me go into global configuration. Okay, so interface FA6/1, and then the command to enable trunking is going to be switch port mode trunk. Alright, and if we type in do show interface trunk, now we can see that we have port FA6/1 in trunking mode. The native VLAN is 1, and the VLANs allowed on this trunk are 1 through 1005. For security reasons, it's good to change the default native VLAN from 1 to an unused VLAN. So this trunking line will be its own VLAN. So let's go ahead and do that, and the command for that is going to be switch port trunk native VLAN. Let's make it VLAN 30. And then VLANs allowed on the trunk. Since we only have two VLANs in this network, we're going to go ahead and just allow only those two VLANs. So the command is going to be switch port trunk allowed VLAN 10 and 20. Now if we type in do show interfaces trunk, now you can see that the native VLAN has changed to 30, and the VLANs allowed on this trunk are VLANs 10 and VLANs 20. So now that our switch is configured, the interface at the switch is configured for trunking, now we need to configure our subinterfaces for the router. So the subinterfaces are going to be the default gateways for VLAN 10 and VLAN 20. For VLAN 10, the network address is 192.168.1.0. So I assigned the first usable host as the default gateway for VLAN 10. So that the IP address of the default gateway for VLAN 10 is going to be 192.168.1.1. You can use some people like to use the last usable host address in the network as the default gateway, but I decided to use the first usable. It just makes things a little simpler, in my opinion. So let's go into the router, and I'm going to go into configuration, global configuration, and we're going to type in interface FA0/0, which is the interface on the router. And then to create the subinterface, we're going to type .10, and that's for VLAN 10. So now we created a subinterface. Now we have to type in the command encapsulation .1Q10. So what this command does is it allows the encapsulation in the frame of the .1Q tag. So what the .1Q tag is the 802.1Q protocol that switches use to tag which VLAN the frame is associated with. So whenever a frame moves across this trunk, it's going to be tagged with the VLAN that it's associated with. So if you're going from VLAN 20 to the router, when you send out that frame is going to be encapsulated with a tag of VLAN 20. So that way, the switch knows that it's tagged as VLAN 20, and then when it gets to the router, it's going to be tagged as VLAN 20. And as long as that VLAN is allowed on this trunk, then that frame is going to move across to this interface. Okay, so now that we've configured the command to encapsulate the .1Q VLAN tag, now we have to assign the default gateway to this subinterface. So it's going to be the command of IP address 192.168.1.1, and then it's a /24 network, so 255.255.255.0. Okay, so now we have to configure the subinterface for VLAN 20. I'm going to type in interface FA0/0.20 for VLAN 20. Encapsulation .1Q20. IP address 192.168.2.1. So the network address for this subnet for VLAN 20 is 192.168.2.0. So again, I use the first usable host, which is 2.1, and it's a /24 network as well. So 255.255.255.0. All right. So now we should be able to ping from one VLAN to the other. Let's go into PC3 to command prompt, and let's ping PC2 in VLAN 10. Ping 192.168.1.3. We should get 3 replies. Perfect. All right. So one cool thing that you can do in Packet Tracer is simulation mode. And you can actually see that frame travel throughout the network. So let's ping that same IP address, 192.168.1.3. And if we hit play, that frame is going to go from PC3 to switch 1. Switch 1 is going to check its MAC address table, and it's going to see that it has it's coming from the source IP of 192.168.2.2, which it has in its MAC address table, and then it's going to also check its MAC address table for the next hop. The next hop is going to be the default gateway that we set up for VLAN 20, and that's also going to be in its MAC address table. So now the next step is it's going to encapsulate that VLAN 20 .1Q tag to this frame, and it's going to send it out of interface FA6/1 to interface FA0/0.20. So if we press play, it'll get to the router. So the router is going to receive that frame, and it's going to see that its destination IP address is 192.168.1.3. The next hop for that IP address is going to be the subinterface of FA0/0.1.0, which is the VLAN 10's default gateway. So it's basically going to go into the router and go from .20 to .10. And now it's going to be tagged as destination .10. So it's going to have the .1Q VLAN 10 tag as it moves back across the trunk. So if we hit play, so it goes back to switch 1. Switch 1 is going to receive that frame through FA6/1. It's going to look at its MAC address table and the .1Q tag, and it's going to see that the MAC address assigned to 192.168.1.3 is in its MAC address table, and it's going to have a VLAN tag of 10. So these will become access ports, meaning that now the switch can send frames to VLAN 10 because it's been tagged as VLAN 10, and it's going to send that unicast message to PC2. And then PC2 is going to do, that whole process is going to repeat but backwards to send the reply. And that's router on a stick and inter VLAN routing and how it works. Thank you for watching.